ground to ground projectile. This projectile is also called as oblique projectile. If you throw, if you projected any projectile with some velocity u making an angle theta and it moves only under the influence of force of gravity is called an oblique projectile. This point is called point of projection and this point is called point of landing. So here point of projection is from ground and point of landing is also ground. That's why this is a ground to ground projectile. So consider this is a x-axis and this is a y-axis. So now this u is resolved into two components. So this u is making an angle theta with this axis. So this we can written as u cos theta and perpendicular to this component we can written as u sin theta. U cos theta is the horizontal component of velocity. U sin theta is the vertical component of velocity. Already you know very well horizontal component of velocity remains constant throughout the motion. So here also u cos theta, but vertical component of velocity decreases while it is going up. So after some time your vertical component velocity is not u sin theta, it is some velocity vy. So here b is the topmost point. At topmost point the vertical component of velocity becomes 0. Now at topmost point it has only horizontal component of velocity, that is u cos theta. So here after reaching the ground the horizontal component of velocity remains constant, that is u cos theta, but the vertical components here, these two are at same line. So it with how much speed while it is going through this point, with same line while it is coming down, it strikes the ground with the same speed, with the same velocity, but in opposite direction. Right, at a point a, at a, so write the vector, that means here velocity is vector, so write the velocity in vector form. So we can write u, initial velocity u is equal to u cos theta I cap plus u sin theta j cap. So this is the initial velocity at point A. This angle is called angle of projection and u is here initial speed. Already we know very well acceleration along x direction is equal to 0 and acceleration along y direction is equal to minus g. Then at top B, at topmost point, here B is the topmost point. So at topmost point it has only horizontal component velocity, that is u cos theta. The vertical component of velocity is equal to 0. Then write the velocity at point B in vector form. No, at point B the velocity is equal to u cos theta I cap plus vertical component velocity is 0, that is 0 I cap. Next write at point C. So we know very well at point C horizontal component remains constant, that is u cos theta, but the vertical component velocity is u sin theta, but in opposite direction to point A. So write the velocity in vector form at point C. So we can write velocity is equal to u cos theta I cap plus u sin theta. Here it is in negative y axis, so we can write u sin theta minus j cap. So we know very well at topmost point B it has only horizontal component, that is u cos theta. That means at highest point, here so many children compare this with one-dimensional motion. In one-dimensional motion, at topmost point the vertical component velocity is 0. So here velocity is equal to 0 at topmost point in 1D. But in two-dimensional motion, here vertical component velocity is 0, but it has horizontal component of velocity. That's why in 2D motion, velocity is not 0. Velocity is not 0 at topmost point. At topmost point, that is P. And one more important thing, at topmost point, it has only velocity, that is u cos theta. For u cos theta, the acceleration due to gravity is perpendicular to this velocity. That means throughout the motion, only at this point, the acceleration due to gravity is perpendicularly to the velocity. Next, one more interesting point. Here at this point, what the direction of velocity means, simply direction of velocity is find out by drawing a tangent. By drawing a tangent to the path at the given point. Suppose if you want to find the direction of velocity at this point, simply draw a tangent at this point. It gives the direction of velocity at this point. Suppose if you want to find the direction of velocity at this point, then draw a tangent at this point. It gives the direction of velocity at this point. And one more important thing here, speed of landing. See here, speed of landing and speed of landing and here angle of landing. Theta is the angle of landing and u sin theta is the here u sin theta is the speed of landing. Speed of landing and angle of landing is same in magnitude as during those in a projection. In projection time, what is the speed with what speed? థ్రోన్ ఏ స్పీడ్ తో మనం వేసాం యూ సైడ్. అదే యూ సైడ్ తోటి ల్యాండింగ్ టైమ్ లో కూడా అంతే మ్యాగ్నిట్యూడ్ తో గ్రౌండ్ ని స్ట్రైక్ చేస్తుంది. అండ్ వన్ మోర్ ఇంపార్టెంట్ థింగ్ ఈజ్ వెలాసిటీ ఈజ్ మాక్సిమం డ్యూరింగ్ ప్రొజెక్షన్ అండ్ డ్యూరింగ్ ల్యాండింగ్. During landing and projection, velocity is maximum and minimum at the highest point. Is projected. If a body is projected with a velocity u making an angle theta, then resolve this velocity into two components, that is u cos theta and another one is u sin theta. Then find the velocity of the projectile after certain time t. Suppose after certain time t, the velocity, the particle is here. So we know very well throughout the motion, the horizontal component of velocity remains constant. So at this point also, this is u cos theta, but the vertical velocity, that means vertical component velocity decreases. So the resultant of these two, at this point if you draw a tangent, this gives the resultant of these two velocities, and this resultant makes an angle alpha with the horizontal. This is called angle at any time. Angle at any time. Then find the velocity of projectile after certain time t. First write initial velocity. Initial velocity means at point A, what is the velocity? That is the initial velocity in vector form. We can write u cos theta into I cap plus u sin theta into j cap. This is the initial velocity in vector form. Next write velocity after time t. So velocity after time t. So velocity after time t means we can write, you know very well, from first equation of motion, velocity after time means v equal to u plus at. So write this one along x-axis and along y-axis. Then combine these two. That gives the resultant velocity in a projectile motion. First write velocity along x direction, that is equal to v equal to u plus at. So from this x. So we can write initial velocity along x direction. This is initial velocity along x direction, that is equal to u cos theta into I cap plus, already we know very well, acceleration along x direction is equal to 0. This is 0. So that is equal to u cos theta into I cap. So this is the velocity after certain time along x-axis. Then velocity along y-axis after certain time t. Then write v equal to u plus at, that is vy uy ay. We know very well uy means initial velocity along y direction, that is uy, that is equal to u sin theta u sin theta into j cap minus ay. Ay is equal to minus g. So this is minus g into t. So this is the velocity along y direction. Then resultant of these two, combination of these two velocities gives the velocity in a projectile. That we can written as v is equal to, so vx I cap plus vy j cap. That is equal to, in the place of vx we can write u cos theta into I cap plus vy means u sin theta minus gt j cap. J cap. Clear, my dear children? Any doubts? Any doubts? Then look at the screen. Then look at the screen. First question. If a body is projected with a velocity 20 root 2 meter per second, making an angle 45 degrees with the horizontal, then draw a diagram. See here. So this is x-axis, this is y-axis. If a body is projected with 20 root 2 making an angle 45 degrees with the horizontal. So resolve this into two components. So this 20 root 2 making 45 degrees with the axis. So this we can written as 20 root 2 cos 45, and this we can written as 20 root 2 sin 45. So that means 20 root 2 cos 45 means 1 by root 2. Root 2 gets cancelled. This is equal to 20 meter per second. Similarly, this is also 20 meter per second. So compare this with u cos theta. Initial horizontal component is u cos theta and vertical component velocity is u sin theta. In the place of this u cos theta, we can written as horizontal component of velocity. U sin theta is nothing but vertical component of initial velocity vector. So u cos theta is nothing but 20 meter per second. U sin theta is nothing but 20 meter per second. So horizontal component of initial velocity vector means 20 meter per second. Vertical component of initial vector means 20 meter per second. Then option 3. Option 3 is initial velocity of the particle in vector form, that is equal to u. So we can write here 20, it is along positive x-axis, that means 20 I cap, plus it is 20, it is in positive y-axis, so we can write it as 20 j cap. Next, fourth one, angle of projection. So here angle of projection is already mentioned, that is 45 degrees. Otherwise here, so this is 20 meter per second. So initial velocity of 20 meter per second. So this a right angle triangle, this is theta. So 20 20, here and opposite and sides are equal, then we can write tan theta is equal to 20 by 20, that is equal to 1. If tan theta is equal to 1, then theta is equal to 45 degrees. Clear, children? Next, go to second question. Find the horizontal component of velocity after 1 second and vertical component of velocity after 1 second. So already we know very well. See here, this is 20 root 2 and 45. So after resolution, this answer is 20 meter per second and it is 20 meter per second. So after 1 second, see here, after 1 second means, suppose the body is here after 1 second. See here horizontal component remains same after 1 second also, but vertical component decreases. So horizontal component of velocity after 1 second means that is equal to 20 meter per second. Then find the vertical component of velocity after 1 second. So after 1 second, after time velocity means use v equal to u plus at. You are finding in y direction. So uy ay. In the place of uy, here initial velocity along vertical direction, that is 20. Already we know ay means 10, time means 1. 20 minus 10, that is 10 meter per second. So vertical component of velocity after 1 second, that is 10 meter per second. Next, velocity of the particle after 1 second in vector form. After 1 second, its horizontal velocity is 20 meter per second. After 1 second, its vertical velocity is 10 meter per second. So velocity in vector form means we can write 20 I cap plus 10 j cap. So this is the velocity of particle after 1 second. Then fourth one, magnitude of velocity of the particle after 1 second. So magnitude means two vertical lines, and write root. You know very well Pythagoras theorem already. This concept is explained in vector chapter. So in see here behind of I 20 is there. So 20 square plus 10 square, that is equal to root 400 plus 100, that is equal to root 500, that is equal to 10 root 5 meter per second. Next, direction of motion with the horizontal after 1 second. So after 1 second, here this is 20. After 1 second, vertical velocity is 10 meter per second. So complete the parallelogram, and this is the resultant. It makes an angle alpha with this horizontal. So this is 10. Then use tan. Then tan theta is equal to 10 by 20. 0 0 gets cancelled. Tan theta is equal to 1 by 2. Then theta is equal to tan inverse 1 by 2. So this is the angle gives the direction of motion with the horizontal after 1 second. Clear children? Let's go to next problem. See here, a body of mass m is thrown upwards at an angle of theta with the horizontal with speed v while rising up. The magnitude of velocity after t seconds. See here, a body of mass m is thrown upwards with a velocity v at an angle theta with the horizontal. So resolve this velocity into two components. One is along x, one is along y. This we get as v cos theta. So v is making angle theta, so v cos theta. So this is v sin theta. So while rising up, the magnitude of velocity after t seconds, after t seconds, the horizontal velocity remains constant. Then find the velocity along y direction. So use v equal to u plus at. So y. So velocity, initial velocity along y direction, that is v sin theta into ay means minus g, that is t. Then write the velocity after t seconds in vector form. So in vector form, v is equal to after t seconds. So along x-axis v cos theta. So write v cos theta I cap plus along y direction the velocity is v sin theta minus gt j cap. So this is the velocity in vector form after t seconds. But here find the magnitude of velocity. So magnitude of velocity means two vertical lines. Then use under root. So I పక్కనే ఉంది v cos theta. సో v cos theta స్క్వేర్ చేస్తే అవి రెండు డిఫరెంట్ కాబట్టి డిఫరెంట్ టర్మ్స్ కాబట్టి రెండింటికి స్క్వేర్ చేయాలి. దట్ ఈస్ v స్క్వేర్ cos స్క్వేర్ theta ప్లస్ j పక్కన దాన్ని స్క్వేర్ చేస్తే ఇది ఏ ఫామ్ లో ఉంది, a మైనస్ b స్క్వేర్ ఫామ్ లో ఉంది. a మైనస్ b హోల్ స్క్వేర్ నథింగ్ బట్ a minus b whole square means a square. In the place of a, again two terms. Then do v square sin square theta plus b square, again two terms, g square t square minus 2ab. Minus 2ab means in the place of a v sin theta, in the place of b gt. So already we know very well children. Here take v square common, sin square theta plus cos square theta, that is equal to 1 plus g square t square minus 2v sin theta into gt. So this is the answer. So which option? B square plus g square t square minus 2v sin. So option B is the right answer. Option B is the right answer. Let's go to one more. The velocity of a projectile at the instant A is 2i plus 3j meter per second. Its velocity in a meter per second at point B. Here point A is the point of projection and point B is the point of landing. At point A, the velocity is given 2i plus 3j. 2i plus 3j means 2 meter per second along x-axis and 3 meter per second along y-axis. Already we know very well. So along x direction, the horizontal motion remains constant. It moves with a uniform velocity. So at B also, along x direction, its velocity is 2 meter per second. But in y direction, initially it is in upward direction. But while striking, its velocity is in downward direction. That is 3 meter per second. Then write this one at point B. Write this one in a vector form. So write the velocity at point B in vector form. So v is equal to 2 I cap. Here 3 3 plus 3, but this is in negative y-axis, so that is minus j cap. So this can be written as 2 I cap minus 3j cap. So this is the right answer. So which option? Option D is the right answer.